Hello, everyone. My name is Karthik. As part of CS 109, I've worked on a project to predict the wildfire risk. So, in this presentation, I would like to talk about the wildfire risk prediction using Bayesian inference and Poisson regression. Wildfires are a serious concern for many nations, and it's one of the most devastating natural disasters, and predicting their occurrence is crucial for disaster and preparedness and prevention. The motivation for this project is that since I moved to California from Massachusetts, I've been seeing a lot of wildfires since 2020, and the recent wildfires in Los Angeles is one of the motivation for me to be able to take on to this project. So in this project, we will use statistical modeling and estimate the wildfire risks, and also to predict the number of wildfires per year. And to estimate to do the statistical modeling, we made use of Bayesian inference, and also to predict the number of wildfires, I made use of the Poisson regression. So because the frequency of wildfires is pretty frequent, especially in the Western United States, how can we predict the wildfire risk is what one of the problem statement. What if we could use the probability of wildfires using rainfall data? If we can estimate the probability of wildfires using the precipitation for the particular year, what if we could predict the number of wildfires in a given year? What if we could also alert people with real-time wildfire risks or something? So with respect to data set, I actually went through multiple data sets in Kaggle and also as well as from different websites, but many of the data sets is not really straightforward. And also I found that the synthetic data generation as a option from the one of the LLMs, but I made use of ChatGPT's deep search, and which helped me to actually grab the data from different state weather websites and national weather website to be able to get the specific data set for states of California, Oregon, and Massachusetts, where I kind of got a hold of precipitation data for the California versus the wildfires for the particular year from all the way from 1987 till 2023. So with respect to the methodology and modeling, so we made use of Bayes theorem for the wildfire risk, where we actually have the random variable W as a high wildfire, and P as a precipitation. And we try to kind of make use of the Bayesian inference to calculate the posterior probability of how the probability of high wildfire given any precipitation year. And also, we also wanted to estimate the number of wildfires. For that, we made use of Poisson regression, which used to predict the number of wildfires. It's kind of close to the Poisson distribution and random variable, but it's more like it has some dependency in terms of the lambda value here is kind of dependent on the beta and beta one. So with respect to implementation, I kind of cleaned the data using pandas, and we tried to normalize the data, and we also set the threshold for the threshold value to predict if the given value is a high wildfire risk or low wildfire risk using a median. And I kind of wrote a code, data cleaning in PY, for which I used data frames, and I tried to deploy the clean data set as again another .csv file. And with respect to the model development, as I spoke before, we made use of the median value for the wildfire data to threshold, and we tried to kind of calculate the prior probability by making use of the mean with respect to wildfires. And the posterior probability is kind of computed using the likelihood and the prior probability distributions. And just to make the code a little bit more visualized, like user-friendly and visualized, I kind of deployed the code onto an app called Streamlit, and it's on a Snowflake cloud. I learned this implementation via a few Reddit channels as well as one of the LLMs, where it kind of helped me to think of ways on how I can show the data. As you can see, these three different kind of views of how the wildfire risk is in California, Oregon, and Washington, with different precipitation values. Real-time alerts, we also kind of use the API data from the respective states, which will actually give you the real-time alerts for the wildfire risk in the respective states. The results, we can see the results on the UI, and I'll go over the UI and how the results are visualized with respect to the color coding and all. So here's the repository. In the repository, I kind of shared in the grade scope as well how the respective code files look like. So this is the actual what the weather data which I initially got, and this data is, as you can see, this data is completely super messy and it's not super clean. So we try to clean this data using the data clean.py, and once I clean the data and kind of normalize, this is how the data set looks like. And then we try to deploy the code using initially Bayesian inference just to check how the data actually looks like in terms of are we getting proper like proper mathematical calculations or something. So I kind of calculated all the uh, posterior, prior, and likelihood data. Once I get confidence that the data, the Python script was actually getting the enough probability, then I try to go over to the Streamlit.py where I kind of deployed the code onto the Streamlit app. And we kind of loaded the data set and we made two independent functions, one for computing the wildfire risk using the Bayesian inference, and other one to predict the wildfire count using the Poisson regression. And we also kind of made a function which actually kind of parses the wildfire risk from the Bayesian inference and applies the respective color coding to the respective state maps. We also have a function which actually applies the real-time fire alerts, and this is the function which does that. And once we have everything, we also kind of apply some jiffies just to say what's the current warning or risk level. But yeah, this is the main function which actually pretty much applies everything. And what are the data we are getting from previous functions is written to the Streamlit app using st.write and other respective Streamlit modules. So I will just show you how the app works in action. So this app is actually is pretty much alive since I deployed the code. So I'm gonna randomly select state of Oregon and I'm gonna enter, okay, what's the risk of wildfire for 23 inches for the particular wildfire year? It will give us a prediction saying the probability of high wildfire in Oregon is 23 inches is 96%, and the predicted number of wildfires in Oregon is 1765. If you click on the volume icon, it will also show you the number of wildfires for the particular year. So as you can see, even though the expected risk for wildfires is high in the as as per the estimated value, but the current wildfire risk is very moderate as per the state of Oregon's API fire alerts. Then we can actually go and see how does this look like for California. For California, if you enter 27 inches, this is considered as a low risk. But if you do the same thing for state of Oregon, 27 inches is considered as a high risk. So we get this data depending on the historical 30 years of data from 1987 to 2023. So I'll also want to show you about the state of Washington. If I enter a value of 36 inches, 36 inches is considered as high risk for Washington. But if you enter the same 36 inches for state of Oregon, it's considered as moderate risk. So yeah, I just tried to play around with this multiple times, and I was able to showcase that this is actually working pretty well, and it actually gives you the real pretty much estimated wildfire risk for the particular precipitation value, and it also gives you the real-time alerts just so that the user is not really misguided or misled. I think this is a pretty good app, and I think for the future, I'm trying to think if I can try to include more variables like wind, temperature, and some other variables like the amount of fuel available for the particular state, and which triggers the wildfires in general. But I felt like this is a good start, and it's a very good learning experience because I was able to make use of the um, knowledge I had from the probability, as well as I was able to learn about something called Streamlit where I can deploy the projects. And yeah, I think this is a very good learning experience for me to be able to deploy the stuff which I did onto a real-time application, which is a good learning experience. Thank you so much.